Thank you for joining this morning. And this is the third part of the Titration Insight series, the webinar series. So thank you all again for attending this morning and taking some time to join us. So I'm Jim Pisano. I'm the Systems Engineering Manager on the Titration team. And joining us this morning will be Chris McHenry leading our presentation. Chris, if you just go advance one slide there for me, that'd be great. Okay, Chris. Stand by while we get the slides rolling here. Chris, can you advance to the next slide? Are you there? Cynthia, are you there? Oh, there we go. Okay, great. All right, thanks. Chris, I don't know if your audio is up either, just so if you want to test it.
Yeah, sorry, it's
okay.
Hanging a little bit, so.
Okay. Yeah, we need to get back to the content.
Yeah, I'm sharing it. Sorry.
Okay, there we go. Great. So as most of you know, I think we have a lot of return people here, attendees for the series. So this is the webinar series is meant to be a one story about titration and how it can help you understand the dependencies of your critical apps and segment apps, and then also actually protect them and provide enforcement capabilities to implement a zero trust security model in your data center. So this is part 3 of that series. And the recordings for the first 2 are at the registration link where you registered to get onto this session. So if you want to go back and catch up on the first 2 episodes, that would be great. Chris, if you can move ahead to the next slide, that'd be great. We'll,
yeah, give me a second. Here. I'm changing the way that I'm sharing.
Okay, cool.
Can you see this now?
We don't see anything right now.
Let me try one more.
Nothing yet.
Nothing? Okay.
Nope.
Sorry, I was trying to get rid of the lag. Let me try one more time. My apologies. This was literally working like 2 minutes ago.
Okay. Nothing yet. It's starting. Almost there. Yeah, nothing yet. Just says you're. Oh, there we go. Okay. We don't have you in presentation mode, but the slides are up and I see your PowerPoint. There you go. Okay, great. Yeah, if you want to move to the next slide, in that slide 3 there, Chris, we'll keep rolling.
This one?
Yeah, the next one.
This one.
Yep, great. So as we said, this is the 3rd and the 4th series. You can go back to that previous one. I'm sorry, Chris, I'm messing you up here. I just wanted a quick review. Okay, anyway, the welcome, I've consumed my welcome time. Here's the bottom line, a couple of things. Q&A, please put your Q&A in the Q&A panel, and one of the panelists will pick that up for you to respond to. And like I said, the recordings are on the registration page. So if you want for the previous sessions, session 1, which was presented by Mario and was the introduction to titration. Last week we had Loy go over cloud workload protection, how to do baseline security policy model for your workloads, and then also how to selectively enforce those and model that enforcement. This week, Chris is going to go more into full stack of forensics and vulnerability dashboarding and walk you through some of those aspects of tetration. So with that, like I said, just if you could put your questions in the Q&A panel. We have people muted because we have too many attendees to do that, but we're going to kick it off now. And Chris, it's all yours.
Okay, great. Thanks, Jim. So today we're going to dive into some of the more advanced kind of real-time security features that tetration has, as well as, we talked a lot about the fundamentals of workload protection and some of the theory behind why we built the platform, how we can start to take a more proactive approach with the way that we approach security for workloads specifically, how we can leverage different techniques, different algorithms to detect the way that workloads work because they have a different behavioral profile. And today what we're going to do is we're going to double click into some of the advanced features, some of the enhanced visibility that tetration brings to help us make very targeted decisions with how we ultimately secure our workloads, as well as detect when our workloads are behaving in ways that aren't normal and might indicate a potential breach. So we're going to dive today into two specific features: the way that tetration understands vulnerabilities and how that can steer us towards more effective proactive workload security, as well as that detection capability and the forensics that comes along with it, the ability to go back in time, use the visibility that tetration has to ultimately understand how a breach happened, where it happened, and enhance our ability to respond to it. So when we look at tetration, there's really four key categories that we target to help customers more effectively enhance their workload security. We looked at a couple of those in the last 2 weeks, specifically Loy's session last week with application segmentation, really focused on how we can help customers contain lateral movement, right? If we have an attacker that gets access into our environment, how can we prevent it from moving from one system to another, where that initial exploit might not have had any sensitive data, but the ability to pivot allows them to access sensitive data. We talked about how the ability to track compliance is really an important part of that, not just day 0 in terms of implementing segmentation, but also day 2 and beyond. Today, we're going to focus on a little bit more of the behavioral anomaly side of things, take a look at some of the other interesting things that tetration is doing from a visibility perspective, as well as an alerting and reporting perspective, and giving us the ability to go back in and look at historic behavior. And we're also going to really focus on not just how we can contain lateral movement, but how we can use enhanced understanding of the posture that the workload has with things like vulnerable software to effectively and in a targeted manner reduce our attack surface. So let's take a step back and just look at what tetration is and the different types of things that we're seeing when we deploy tetration in our environment. So we're going to focus again today on visibility and forensics. A lot of people, when they look at tetration, and we talk about things like network segmentation, look at or have an understanding that, yes, of course, we're seeing how workloads behave in the environment from a networking perspective. In order to effectively implement application segmentation, I need to know how things communicate. I need to baseline how they communicate. I need to understand how that would work in the context of application segmentation policy. But we're not just capturing data on how the workloads behave from a networking perspective. We're also looking at things like identity information. Who are you? What user are you? What application do you support? Where are you in the environment, or where are you on the globe from a geo-IP perspective? We're also looking at things like process behavior. Process behavior is something that we're going to double click on today. And one of the really interesting things that we do with regards to things like detection and forensics in a breach type scenario. We're looking at how those processes are running on their host. We're baselining how the processes interact with other processes. We're looking at the software that's installed that's running those processes to help understand risk. And then lastly, we're doing that to start to build a baseline of the environment as a whole, so we can understand when applications that are important in your data center start doing things that they really shouldn't be doing. So let's take a look at the architecture real quick. We talked a little bit about that data that we're pulling in. One thing that's important to understand is that there's really 3 different kinds of information that tetration is gathering. There's things that it's gathering natively as it starts to build a profile of the workload. That's leveraging tools like agents, and whether that's the tetration agent, things like Cisco AnyConnect, integration with load balancers. There's also that identity information, things that come from your environment, tying into systems like Infoblox or VMware or Kubernetes, ServiceNow. And then there's things that we bring to the table from a platform perspective with regards to intelligence. One of the things that we're going to look at is some of the different threat intelligence feeds that come into Tetration natively out of the box. Things like always up-to-date information from vulnerability databases like the NIST CVE database. Understanding things like geo-IP information, where an IP address comes from. That's native threat intelligence that's dynamically pulled into Tetration from the cloud. We're also looking at things like process hash intelligence. We have behavioral rules that are in the system. And all of that comes in concert together to help you build a good picture of the posture of your workload, the behavior of the workload. And it allows us to go in and help understand when things don't behave as expected, what is actually happening, and how can I address it? So the first thing that we do when you deploy Tetration in your environment on a workload is we start to build a profile of that workload. Tetration is tracking every workload, not just systems that have agents installed on it. We want to build a profile of overall behavior in your environment. That being said, if you're leveraging the agent, you're getting more detailed information on the OS, we can start to build a really detailed understanding of how that system works. And we give you the ability at any point in time to go to any workload in your environment and get a good picture of what that workload looks like from a behavioral perspective. Looking at things like processes that are installed, packages that are installed. Search is a huge part of the product as well. So while we look at this from the perspective of an individual workload, where this really starts to become powerful is when I can actually look at the environment as a whole and start to say, hey, show me everywhere that this particular process is running, whether that's the process command line, whether that's the process hash. We can also look at things like commands that have been run on the system. What makes this really interesting is it gives us a suite of tools that allows us to look at a number of different indicators of compromise that you see in the threat intelligence community and start to try to understand where we might be impacted by that. At the end of the session today, we're going to take a look at a demonstration from a real-world example of breach detection and forensics that leverages some of these tools to help understand the scope of impact as we're going in the environment. Now, visibility, baselining, something that's really important to help us just start to get good hygiene in our environment and prevent, so that we know what's happening, because it's very difficult to defend something when you don't know what you have. But just having that data is really not enough. Many of our customers have thousands, if not tens or hundreds of thousands of workloads in their environment, and they may not even be in the same location. They may be in multiple different clouds. As we've discussed before, Tetration is designed to work in any cloud. But what we really need to do is we need to start helping you take that information, not just give it to you as a whole, but understand how you can actually start to take action against it. So one of the components here that's really important to understand when we start talking about things like attack surface is what can be attacked. Now, vulnerabilities are interesting. One of the things that Tetration does out of the box is it looks at the workload, it understands what software, what versions of software are installed on it. We can use that information to both understand potential footprint of installed software, as well as even potentially write segmentation policy or application segmentation policy. Vulnerabilities are important because it's one of the core pillars of workload foundation, the foundation of workload protection is understanding what software is installed, how it could potentially be exploited, and then building good hygiene practices around the way that we manage our workloads. Now, we all know that it's one thing to know that a vulnerability exists. It's a completely different thing to know whether it's exploitable. And then it's a third thing as well to have an operational process built around that to make sure that things are patched. So we want to help you understand where these vulnerabilities exist, but not just where they exist, how we can ultimately take action against them. So the first thing that you'll see with Tetration is we give you a way to visualize information about what's going on in your environment. It's not just about looking at an individual workload and seeing what software is installed on it. We come with a built-in vulnerability dashboard that allows you to go in, understand different vulnerability scores aligned with NIST's paradigms. It allows us to look at things like which vulnerabilities are remotely exploitable, what the score of that vulnerability is. And this is really interesting. We can look at, let's say a new vulnerability comes out. You want to understand the scope of impact. we can very quickly go in, filter out for that particular vulnerability, and understand every workload in our environment where that vulnerability is running. So this is pretty interesting, right? But it still doesn't give us a way to take action against it. So another score that we have in the environment, another important dashboard, is what we call the composite security score. So raw data, that's really what the vulnerability dashboard is. The composite security score is designed to help us both respond to incidents as well as take targeted action against the state of our environment. So you can see when you first log into Tetration, this is actually the first thing that you're going to see. And when we start to build, without any input from the user, a score of the applications in your environment around how risky they are from a baseline behavior perspective as well as a posture perspective. And there's 6 different categories that we score against. The first one is the presence of the vulnerability, which is essentially an aggregate of that data that we just showed you. Now, what's really cool about these scores is they're all relevant to the applications. So one of the cool, fundamental components of Tetration is the ability to build role-based access control. And one of the things that we want to do is we want to start supporting a shared security model where application owners can start to take some ownership for the security of their applications. Because the reality is, in larger organizations, this is an extremely difficult thing to have a handle on, and it's not something that's easy for just the security operations team or the network operations team to target. We want to start building a culture of security, but in order to do that, we also need to give people targets to achieve. And so one of the things that we've done as we've built these security scores is we've enabled them with role-based access control so that an individual application owner can always have a real-time and historical view into the posture and the score of their application. And then from an InfoSec perspective, you can have a view of the global environment, which applications are most at risk, and how we can start to take action against it. There's 6 different scores that we leverage today to contribute to the overall security score. First is an understanding of the packages and the risk that's associated with those packages from a vulnerability perspective as they are installed on the host. Now that's interesting, right? But as we all know, the presence of a vulnerability doesn't necessarily mean that it's exploitable. And there's oftentimes controls that we may have wrapped around that, whether that process is there but not running. It might not be listening on the network. And so we need other data in order to really make that actionable. The second category that we look at is really both an analytics category based on how we view the processes that are running in an environment, as well as a threat intelligence category where we can actually pull in from threat intelligence sources an understanding of process hash and malicious process hashes. This is a really strong indicator of compromise. If you have a process hash that is known malicious, that's a really good place to look. And that's something that would easily show up on this dashboard, both for an individual application owner as well as the security organization as a whole. We take all that information though, and we combine it into a score that's probably, in my opinion, one of the most powerful ones, which is the attack surface. This is a combination of different metrics, and we're going to dive into this in a little bit. That is designed to help us understand risk of the application and really take targeted actions against that to improve the security of our workloads. Forensics, this is what we're going to dive into with regards to process behavior detection. We're also baselining network behavior and things like data transfer. All of these scores are calculated in real time, and we can also go back historically. So if you want to see when a vulnerability was introduced in your environment, all we need to do is click back in the timeline, understand when that presence was had started. So we're going to dive, and right now we're going to specifically focus on how we leverage all of this information to take targeted action with something like the attack surface score. So the dashboard is interactive. If we focus on attack surface, we're going to double click down into 2 different areas of the environment. First thing we're going to do is how we can potentially take action against this. You can see on the right-hand side that we list out in order of the worst scoring vulnerabilities that are present, the actual applications that are a part of it. So you can see in this particular environment, the application that is my scanner application is pretty much the worst, but honestly, it's kind of tied. And this is pretty normal, right? Because if you have a relatively consistent deployment process for operating systems, there's probably a lot of commonality that you're going to see in vulnerability. And too much data is not always a good thing. So you can see also on the left-hand side, when we look at our workload scores, a ton of bad workloads. This really looks terrible, right? But it's also not very actionable because I can't just go and say, I need to patch everything right now. We need to help you make meaningful incremental progress. So let's take another look at this time at the attack surface score. You can see that our attack surface score is a little bit better. And one of the fundamental things that we use to contribute to attack surface is that vulnerability information. But this time you can see that we're getting a much more interesting delineation in terms of where the risk lies in our organization. And you can quickly see that VDI is actually the most risky application. And we've highlighted 3 individual servers that have the most risk from an attack surface perspective. So what is attack surface? If we double click down here, you can see that attack surface is actually a metric that's combined with all of the different data sources that Tetration is collecting. We're looking at network behavior, we're looking at vulnerability, we're looking at the process and the package and the ports and protocols and what's used and what's unused. When we double click down into this particular workload, you can see that there's 4 ports and protocols that are in use here, but there's 2 that we've never seen used, and 1 of them that actually has a vulnerability. So very quickly, we can get some actionable insight into places where we can make a meaningful impact in our security posture. Now, if you're leveraging application segmentation with Tetration, there's a couple different ways that an application owner or a security team can take action on this. The first way is you can use this data to ultimately patch things. But with application segmentation capabilities that Tetration brings with the agent natively, we can also simply go in and close this port leveraging a segmentation policy. And that builds a feedback loop that allows us to actually improve the attack surface score. This becomes really powerful when we think about how customers operationalize this, because as a security organization, we can actually give a metric to our application owners that say, hey, because of this data classification that you have on your workload, you need to have an attack surface score for your application of greater than 75. And then we can empower the application owners to actually take action against that, whether that's leveraging the native capabilities of Tetration or whether that's leveraging other mechanisms. But we want to give you meaningful, actionable insight into how you can better improve your attack surface. So this is really powerful because it leverages a number of those different components that we're pulling in, inclusive of things like threat intelligence. You can see process hash here, and the vulnerability data that we mentioned earlier with the vulnerability dashboard. So we don't just want to give you raw data. We don't just want to allow you to search and understand inventory. We actually want to also analyze it in a way that allows you to take action against it. And attack surface is a really powerful component of that. You can see when we dive down even further, it allows us to pivot directly into research with NIST, so that while we're making an assessment, you can also make an assessment on your own, and then ultimately determine what action you want to take against it. So that's vulnerability. That's an understanding of the dashboard, and also some of the advanced analytics that we run against the data that we're gathering from both a process hash, threat intelligence perspective, and the vulnerability perspective to help you make a meaningful impact on the proactive security posture of your environment. For this next section, what we're going to dive into is the forensic score in that composite security dashboard. And what that's looking at is that's actually looking at the process behavior and the way that those processes on that workload might be anomalous and be cause for concern, or at least an opportunity for us to go in and research potential, to go do threat hunting. So we talked a little bit about how Tetration obviously gathers a lot of information on network behavior, but we're also monitoring process behavior. And this is a completely, it's an independent set of data where we allow you to kind of go in here and look at it, but we do also merge that, and we'll show you what that looks like in a, in a real world example. So monitoring processes. We're monitoring every single process that executes on a host, and we're actually also monitoring for different behaviors of those processes. We're looking for key indicators, key behavioral attributes, things like privilege escalation, shellcode execution. We're monitoring every single command that gets run on that host, so you can go back and search and understand if a particular campaign, malware campaign goes, and one of the IOCs is that it executes a particular PowerShell line. It's trivial in Tetration to go back and understand every single workload where that exact PowerShell command has been run. This is really powerful, and the raw signals are really the foundation that we use to build out these detection capabilities. But in addition to understanding raw signals, we also give you the ability to write rules on that, and we ship with built-in rules out of the box. So one, just as an example of the most fundamental rules that we see with Tetration, is there's a built-in rule that tracks every new shellcode command that's been run as a child process of a known web server. That behavioral indicator will capture every single remote code execution vulnerability or exploit for any web server, because it's not looking at a specific profile for that particular behavior or a specific profile for that particular attack. It's actually looking at the behavior-oriented things. And this is just an example of how we can leverage different algorithms and why workload protection is a unique arena compared to traditional endpoint detection, because these kinds of whitelist-oriented behaviors are much more in line with the consistent and repeatable behavior that we see in workloads. We also, in the most recent release, shipped with a number of rules that are based on MITRE's attack matrix. And so we can start to get a more detailed understanding of how exploits might relate back to traditional or common attack techniques. Primarily, again, focusing around how we can leverage things like whitelisting and that perspective in the servers to build an accurate baseline of the way that the server or the workload behaves, because it's much more of a meaningful thing to see a server deviating from normal behavior than it is a traditional end user. Now, we come with a number of built-in rules out of the box, but we also do give you the ability to create your own rules, leveraging a number of different criteria around those fundamental signals that are in the product. This is an extremely powerful way for us to add tooling and visibility into our environment. And anytime you see a rule trigger inside of Tetration, this is obviously also something that can integrate with other security tools, feed alerts out to a SIEM, allow you to integrate this into your SOC workflows. So it's interesting to take a look at the actual techniques that we're leveraging from a visibility perspective. It's another thing to look at it in the real world. So to demonstrate the behavior and the workflow with Tetration, we ran an experiment. And we put a virtual machine out in AWS running Apache Struts with the vulnerable version that was attacked in several notable attacks a couple years ago, about a year and a half ago. And we just put this out on the internet. We really didn't do anything special to it. We didn't add DNS to it. We didn't put SSH on. We enabled SSH, but SSH was locked with a certificate, and the website was really just running on 8080. Not even in the root folder. It was running in the default Apache Struts folder. So this is pretty crazy, right? Because we're not pointing to this server and saying, hey, come attack me. But one of the wild things that you'll see, and anyone who's a security professional has probably tried this before, is literally just watching that by the presence of something on the internet, everything that someone tries to do on it. One of the things that, one of the rules that comes out of the box with Tetration, or one of the fundamental signals that we track, is things like user logons, tracking what a user does on the system. And just having port 22 open, seeing all the different people that try to log on from different IP addresses with different default usernames and passwords is truly crazy. I mean, it is at minimum 10 an hour just by being present with an IP address on the open internet. So we put this out here and we were waiting to see, maybe something interesting would happen. And very shortly after that, a couple things happened. The first thing that happened was we actually started to see our composite security score drop, and we had set up some alerting to get alerts when that security score started dropping. So we saw a noticeable degradation from a forensic perspective and a noticeable degradation from a network anomaly perspective. The network anomaly is where we're baselining data transfer in the application. So what that means is that for the most part, this particular server was acting as a server, and all of a sudden it was acting as a really strong client. And then about 15 hours of that, we get an email from Amazon saying that we're starting to scan the internet. So needless to say, we'd received a couple different signals, and it was probably time for us to do a little bit more digging. So what we're going to do is we're actually going to pivot over to the live Tetration environment now. We want to be very good, responsible citizens, and one of the things that we'll say, let me share this real quick. And one of the things that we'll say is that immediately after we discovered this, we locked down this environment. So while we do have essentially a static view into what's going on, this is no longer behaving as part of a command and control or a botnet or anything like that. It's heavily locked down, but it does give us the ability to continue to do forensics and to go back in time, both look at the real-time state of the workload, as well as understand how that workload was exploited. Because one of the things there's two fundamental questions that typically come up anytime we're doing an IR exercise. The first one is, what was affected, right? Can I see, I know one particular machine was potentially exploited because that's where I got our alert, but is that where that stopped? Or do I need to look at other places? And so being able to leverage the combination of information that tetration has from a process behavior perspective, from a network behavior perspective, following users as they log on and they pivot between systems, looking at things like exploits, really becomes a powerful tool as a part of this forensics process. Now you can see when we first log into tetration, there are two very heavy indicators of things that are going wrong in this environment. The first thing is you can see we have a process hash score of 0. And the second thing you can see is we have a forensics hash score of 0. And we want to be able to dive down deeper and understand what's going on in this environment. Now at the time, when this exploit initially happened, this hash was actually unknown. So I mentioned that we got a couple particular alerts, but from a hash perspective, there wasn't any anomalies that were showing up. Now, in the current environment, you can see that we do actually have some anomalies that are shown here. And this is now that the industry has marked this particular hash as malicious and we're pulling in industry information from a threat intelligence perspective, we can very quickly identify where the risk is, both from a workload perspective, the workloads that are actually impacted, as well as additional information from a research perspective to understand what the file was, what the category and how it was determined to be malicious, and we can actually take the hash, copy that out, and use that to do additional research from a threat intelligence perspective. Now, the presence of the hash is interesting, but what if I don't have that? That's where forensics comes into play. So from this dashboard, again, we see the workload that's been impacted, and I want to dive in and understand the exact scenarios that caused us to get exploited. So from the dashboard, we pivot out into what we would call forensics analysis. And this is taking a look at all the different events that we've captured after we baseline the way that these workloads are behaving from a process perspective. And we can start to dive into exactly what's happening. Now, again, search is a huge part of the platform. We want it to be extremely responsive. We want to be able to go back in time and understand what's happened in the past. In this scenario, what we've done is we've filtered out to just look for forensics events that triggered against that workload at the period of time that we know that we got exploited. Now, there's a lot of other really interesting searches that we could run here. Now that we know that this particular binary was called mini tools, we could look for all behaviors in our entire workload environment, in our entire data center, across our entire organization that were related to mini tools. So I can see every process on every server that has ever been associated with this particular binary. Another way to look at this is once we figure out how it was exploited, we can start to build behavioral criteria and understand where have we seen similar behavior in the environment and dig down. In this scenario, the second thing that we want to figure out, so we talked about scope being a really important part of an IR exercise. The second thing that we really want to understand is how do I clean this up? And in order to clean it up, we really need to understand what happened. So if you look at the way that an attacker exploits an environment, they want to be able to get initial access to the environment. They also want to be able to establish persistence. And if I ultimately want to clean something up, I need to understand both of those scenarios. How did they get in? How can I prevent them from getting in again? But also, how can I understand what they did and what I need to clean up in order to do that? So here we can go back and we can actually walk through the exact steps that the attacker took in order to exploit this environment. You can see 3 commands that were run. And these are actually slightly out of order for a slightly different reason. It's because this is a slightly older version of software that's been fixed. So we can look at the order that these were actually executed. The first thing that you can see is that this host created a wget. That's very odd, right? Because when we look down here, we've never seen this host do a wget, and I want to understand what actually happened. So what you can see visualized here is the process tree that executed that wget. And what's really strange is that that might be normal if we see a user coming in and SSHing into the system and downloading some software and doing something like that. Still interesting to look at. But in this scenario, you can see that the parent process was not SSH. It was actually Apache Tomcat, which we know is vulnerable from the packages that we've seen installed earlier. And you can see that as a child process of Apache Tomcat, they executed this wget. This is classic remote code execution. We can see the IP address that they went to, the port and protocol that they went to. We can see that Minitools binary that was downloaded. If you look at the other two actions that we saw on that screen beforehand, you can see that the next step that they do is they do a chmod to modify this and makes it executable, and then they execute Minitools, and we can see all of the different things that Minitools does, including adding itself to initd, so that when we reboot the software, that attacker now has persistence, and we could patch Apache struts, and they would still have a presence in the environment. What's really also powerful about that is I know exactly where they downloaded this, and exactly how to delete it, and exactly how to remove their persistence. So forensics is really powerful. The next thing I want to see is what they did in the environment. So this is where it becomes really cool for us to be able to pivot from the behavior that we saw from a process perspective into the behavior that we see from a network perspective in the exact same system. So what you can see here is this time we're going into our flow search capability. We're looking historically, and we're seeing the network behavior for this particular host around the exact same time that we had the exploit, around the exact same time that we saw the scores disappear. And we're going to do a really interesting search here, which is not show me a port or a protocol. This is actually, I want to understand what this process did from a networking perspective. This is really powerful because if you think about an IR exercise, one of the things that we want to be able to do is we want to be able to understand how systems get pivoted through. So I can see that process. I can see the processes that were executed. I could see if this particular Minitools application then opens a connection to another site and starts communicating with something else. This flow search is searching on the behavior of that process, right? So what we did is we searched for any time we saw network traffic that was originated by a process that contains Minitools. And this is going to do a couple different things. It's going to show me how it's communicating. We can quickly see port 4880. This is probably the command and control channel. We can also see the IP addresses that were actually initiated here. So you can see that down in the table over here, all of these IP addresses are sourced from this individual workload. The destination IP address is actually the same one that was downloaded from, and we start to get a really good picture of the scope of who's been exploited by this. Now, for that scope, I could do a number of different things. We could look and see there's a lot of different ways we can find that question. We could look and see every system that's communicated with from an IP address perspective with this process. We could go into the inventory and search for every system where that Minitools process is installed, every system where that hash is installed. So we have a really good understanding of scope. We have a really good understanding of what that process did on our network. And now we have enough information to take action against it. Now, there's a lot of different things we could do here as well. The first thing we could do is we could go in and we could delete the process. But I might not actually have access to that server as a security admin. So from Tetration, we can actually go in and we can also take action against this with an application segmentation policy. I now know that the command and control channel is 4880, and I know the command and control address that that particular botnet is trying to communicate back with. I have baselined this application, and one of the things that I can do is I can validate as well that this command and control traffic was not part of the baseline. It's not permitted in our policy. We're in a simulated phase with this policy. It was about to get launched, and what we're going to do here is we just put in that traffic, and what Tetration has told us is if you were to have implemented this policy, this command and control communication never would have happened in the first place. If you want to shut it down right now, go for it. You can see policy denied here. So the last step that we have is simply to enforce that policy. You could implement this in a number of different ways. We could have enforced this based on vulnerability, based on the presence of a hash, lots of different ways to ultimately build this policy. Simply by clicking enforce, Tetration is then going to leverage its native application segmentation capabilities. And from a single panel, we both went from detection to forensics, incident response research, all the way to actually being able to respond to that event by enforcing a policy that blocked the command and control traffic in the future. That's full lifecycle workload protection. If you want to read a little bit more about this, we did a deeper dive. You can see all the different steps, and we'll publish these slides at the end of the session. Now, threat hunting is also a really important part of this. We walked through that last example in the demo. There were actually multiple different exploits on these systems, and we're not going to dive too much into this. But we looked at this from the perspective of getting alerted. We also have the ability, obviously, to leverage all this data from a threat hunting perspective. And one of the things that we found as we were looking at this particular host was that it wasn't actually just exploited once, it was exploited multiple times, which is pretty typical of things that live out on the public internet. And so it's not just about responding, this is also an extremely powerful threat hunting tool in organizations. So to summarize, we've done several sessions over the last couple of weeks on how tetration can be a really powerful platform to enhance workload security. With application segmentation, we're looking at how we can help customers accelerate their ability to contain lateral movement. And we're thinking about the entire life cycle of the way that that policy works, not just from a day zero perspective or a day one perspective, not just addressing policy discovery or enforcement, but also addressing day two operations, understanding how we track compliance in our environment. Today, we actually extended that a little bit. In the past, we were tracking compliance. In the past sessions, we talked about tracking compliance from a network behavior perspective. Today, we also talked about tracking compliance from a vulnerability and a process perspective, and even how we can start to generate new compliance workflows that enable our application owners to achieve specific targets around application security scores and help to build a shared security model from a compliance perspective that can be monitored and mandated by InfoSec and enforced by the entire organization. We looked at some of the detailed forensics capabilities that tetration has, some of the additional data that we're gathering from threat intelligence sources by monitoring and tracking process behavior and understanding process behavior anomalies. We talked about the unique algorithms that tetration has built in out of the box that are explicitly designed to help understand, detect, record, and alert on behaviors for workloads, right? Because workloads have unique behavioral characteristics in comparison to traditional users. And then lastly, we looked at how we can reduce our attack surface and how we can help customers intelligently reduce their attack surface by taking all of this information into account and understanding where the biggest bang for our buck is going to be as we start to use the limited resources that we have to enhance the security in our environment. So with that, I'd like to thank you for your time. We're going to let you out a little bit early, and obviously if we have any Q&A, we can address that now. So looking through the Q&A,
Okay,
I don't know, are there any unanswered questions that we need to address?
let's just take a look. What do we have? Anything in there right now?
So I think we don't have anything. I'm not seeing anything. We'll hang out for a little bit longer on the webinar. Obviously, if you have any questions, please feel free to put them in the Q&A and we can address them. If not, thank you for your time. Happy Halloween, and I hope everyone has a great day.
Thank you, everyone. This recording will be posted up on the site about 72 hours or so. So, alrighty. Thanks again, and yeah, we can leave this up for a couple of minutes there, Chris, I guess, just in case other people have Q&A. But thanks, everyone.
Hey, Jim, can you stop the recording for me? Thank you.